Alright, welcome to my explanation for the possible solutions for LeetCode number 42 called Trapping Rainwater. So in this question, we are given n non-negative integers representing an elevation map where the width of each bar is 1, and we want to compute and return how much water it can trap after raining. And it's not really explained here very well, but how much water we want is pretty much sort of the area in this graph. So this little blue square here is equal to 1 unit, as it's 1 unit squared. Similarly, this is 4 and that's 5, so we would return, well, that's 1 there, sorry. So we would return 6 for this one because we can trap 1 unit of water in that space, 4 in that space, and 1 in that space without any overflowing. So it's also important to note that we can't use the boundaries of the it's called the height vector here. The integers are given in a vector, and yeah, the boundaries don't act as a wall. As I explain the solutions for these ones, I will just refer to these columns as columns or pillars, just so it's a bit easier to explain. So these constraints, n is equal to the length of height, which is fair enough. N can be between 1 and 2 to the power of 10 to the 4, so we need a fairly efficient solution, definitely no worse than big O of n squared times complexity. And height, each height can be between 0 and 10 to the power of 5. So I've got two solutions here. This first one is the one that I first came up with quickly in less than 30 minutes. Unfortunately, it's a big O of n squared solution, which is not quite optimal. But after I go through this one, I'll go through the optimal big O of n time solution. They also both have, as far as I'm aware, constant space complexity. But so for this one, I'll just explain my intuition and reasoning and how it works. So my idea was just to go through each sort of space for a column, and just in this for loop here, and then we want to sort of see how much water can fit in. So for some water to fit in between two columns, there has to be, two columns or columns with the same height. So for example, this tall one here has height 3. It can only be filled up to height 2 on the left side because of this pillar of height 2. It can't be filled up to height 3 anywhere because there's no other pillar of height 3, if that makes sense. So what I thought we could do is go through each pillar and then just see if any other pillars in the rest of the array of the vector is the same height or greater. After that is, if any pillars after it appear are equal or greater height. And if there is, then the first one we encounter, we can fill with water. And then all we have to do is find out how many squares of water we can fill, and then also how many squares are also blocked off by smaller pillars. So that's what I did. I went for sort of each column, and then I iterated from the highest value, the highest height that column has, and iterate over the rest of the array, just seeing if there's any other columns with the same or greater height. And if there is, we compute how much water's in there and then how much we have to get rid of. And then we do that, and then we move on to the next column, the next column from that space. So just in a bit more detail. So we just go, for each height counting down, we set a little tracker here as found to false, because after that we can use it to break out of this loop of looping down the heights after if we need to. So now we go from int j equals I plus 1, where I is the column we're on. We want to start looking at the next column, starting from the next one, of course, until the end of the array. And so if the height of this column is greater than or equal to the current height of the ith column that we're looking at, I've just got this print, I don't actually need that one. That's just for a bit of debugging. We want to find the area, which is given as the minimum height of these two, which in this case is always I height, or the current height of the first column we're looking at, times j minus I, which is the length. So if this is I, this is 0, 1, 2, 0, 1, 2, 3. This column is 3. And this large column is 4, 5, 6, 7. So we need to get that 3 in the middle. And how do we do that? It's just 7, take 3, take 1, which gives us our 3. And we can transfer that. Same maths. J take I, take 1. And that will work for finding the length between the two pillars, the exclusive length, so not including the pillars. And then of course we just have to minus the height of any pillar and the height of any pillars in between. So we do that is another for loop, starting from the column after the ith one and just going just before the jth column, and we just minus the height of that from our area that we've got there. And of course, while we're doing this, we're keeping track of our total water, and we just add that area to the total water. And then we want to move the I to the j column. And here I just thought we could do it just by setting I is equal to j minus 1. So after we break out of all these and we go to the next iteration of I, it will actually be updated to I equals j. We also set this found equals true just to be a bit more convenient for us. And then we break out of this j loop, and then we check this found condition, and since it's true we break out of that as well, and we break out of the looping down each height of column I, and then that'll bring us back to the original I loop where we can continue from I equals j. So what that means is once we're finished checking these, we would start with I equals here. We would check at this height for any. There's nothing there, so we go to the next one. We check this height. There's an equal one. Unfortunately, with this solution, we still try to do all the maths here, doing all the min height things, and we end up with 0. But then we move on to I equals this pillar. We see that there is another further on pillar that is of equal size, so we get the area between those two and minus this small pillar, and we get 1. And overall that works. Let me just get the time. This one was very slow, it only beat 5% of users with C++ and with runtime, and I mean it beat 20% in memory, which isn't great. So we can actually, there's actually a more optimal solution with bigger of n runtime, which I will now run through. Alright, so this solution uses a two-pointer approach. Pretty much coming in from each end and calculating the water between in the troughs, if that's how you pronounce it, from each end in one pass. So this is much more efficient. So yeah, we initialize our total result here, total water, and then we initialize the 2 pointers, one at the beginning and one at the end, left and right, respectively. And we also want to keep track of the max height that we've encountered, iterating in from both the left side and the right side, just left max and right max. So now we just loop until the 2 pointers meet, so our left is less than right. And so if the height at the left pointer is less than or equal to the height at the right pointer, we then want to check some more things. So if that's true, and the height at the left pointer is greater than or equal to left max, so that means if the height at the left pointer is equal or less than the height of the right, and the height at the left is the highest that we've seen from the left, we want to update left max to the height that we're pointing at now from the left pointer, if that makes sense. Otherwise, so if left pointer is still less than or equal to the right pointer's height, and however we've seen a larger column from the left side already with left pointer, we would be able to add to the total water the left max take the height pointed at by the left pointer. So what that means is if we start here and say our left pointer is pointing at this first column and our right pointer is pointing at this column, then we can see that the height of the left pointer is equal to the height of the right pointer. So now we want to check these conditions. So the left max at this point is 0. So height left it gets updated to be 1. I mean left max is updated to be 1, sorry. And then we go through and we increment left plus. So for the next time we go through this while loop, we're pointing at this blue column here. So we don't worry about this one. We go back up to the top. Is height left less than or equal to height right? Well, it's 0 plus 1, so yes it is. Now, is height left greater than or equal to left max? No, it's not, because left max is 1, and our current height pointed at by the left pointer is 0. So now we want to add to total water 1 take 0, as there's 1 square here, so we can add that. We can add that 1. And then we increment left again, and we're pointing at this one. I'll go through it again. Why not? Because this time right will be greater than left. So now we go through again. Is height left less than or equal to height right? Well, it's 2 versus 1, so no. Now we go to this side, the right side. Is height at the right pointer greater than right max, which starts at 0? Yes, it is. So we update right max. And then that continues again, the same thing pretty much. And then we get to, we have height max equals 2 after passing that. And then once right's pointing there, the left one gets moved in again. Let me just double check. So the left pointer is now pointing at a column with 1, and the right pointer is pointing at a column with 2, as far as I'm aware. So now we update right max because it's not larger than an old right max. So now right max is 2, and now we go again. Now it's left is pointing at a column with size 1, and right's pointing at a column with size 1. It's a bit confusing to follow because it's pretty much doing 2 things at the same time. But hopefully you follow. If you have any questions, just leave them in the comments below. I'll be sure to get to that as soon as possible. But so the main idea is the left pointer here will be keeping track of this this column for as the current left max until it gets to here. As it traverses through this trough here, for every column, it will update total water to, it would add to total water the left max take the height. So when it's here, it will be 2 take 1 to add this one, and then it goes here, it'll be plus 2 take 0 to add that 2, and then there it will be 2 plus 2 take 2, no, sorry, it will be this 2. Total water will be added. I've just got myself lost there, sorry. Let me just start that again. And then once we get to this column, the total water will have added to it 2 take 1, which is 1 for that square. As we're doing 2 pointers at once, we avoid counting sort of these squares here that don't have a wall on the right side. And so we get that by iterating in the right pointer from the right as well until we meet in the middle. And so as left's doing that, I think once it gets to this tool column, well, it's never going to pass that. That's where left will stop, as the height at right will always be less than the height at left. So it would never come back here. We would continue going through the updating the right max and adding to total water right max take height is right. And then after that, of course, we decrement it. So hopefully that makes sense. So we close in from each thing and just count each column, keeping track of the maxes so we sort of know how much to count. until they meet, and then once they meet, I'm pretty sure they would meet in the middle here on this example. We just return total water. So that solution is bigger of n time complexity. This implementation here actually beats 92% of users with C++. I know that's not always super accurate. It varies quite a while, but that's quite good. The memory, unfortunately, is not great. I think that's just because I'm keeping track of a lot of pointers here. Like, I'm not sure actually. If maybe someone in the comments could tell me, but I think asymptotically this is optimal. That should be constant. But still, it is still constant space complexity and linear time complexity. Hopefully I explained that well enough. If you have any more questions, as I said, leave them below in the comments, and I'll be sure to come back to you with hopefully a good answer within, at most a couple of days. If you enjoyed this video and you'd like to see more like it, please feel free to leave a like, comment any feedback you have. Definitely subscribe for more if you like it. I really appreciate it. It really lets me know to keep making these videos. Alright, well, I'll see you in the next one. Thanks.